Hey everybody, my name is Scott Carlson with MTH Pumps. Today we're going to talk about some of the applications of regenerative turbine pumps and where you can look uh, when you're out in the field looking for places to sell. Hopefully this will give you a little bit of knowledge about where to use them and how they apply to different services. So we'll go ahead and get started in this. A little bit about MTH. We've been in operation since 1965. We are a second generation owned family company. Our founder, Dave Tremaine, started MTH, and his son, Tim Tremaine, is now the president, has been for several years now. And so we intend, and he intends on passing it on to his kids when they get of age. So it's going to stay family owned, hopefully for a very long time. We currently have about 85 employees. I know we're supposed to break the 100 employee marker within the next couple of months here. So we're pretty excited about that. And we are located in Plano, Illinois. It's about an hour southwest of Chicago, and we make all of the parts that we sell for our pumps. We make here in our facility. We own about 6 square blocks of the city of Plano, and we have almost every square inch of it occupied with machinery to be able to build product. We are ISO 9000 compliant and 14001 compliant. The 14001 we just got last year, and it entails environmental sustainability and social responsibility. See, and we also own our own foundry right next door to us. So we often have parts available, and it's easier to make sure that we always have the parts you need. A little bit, a couple pictures of our factory here. We do have a full sales office, so when you call somebody or call our factory, you're not going to get a machine, you're going to get a human being. We're here 8 to 5, Monday through Friday, Central Time. Our application engineer comes in at 7, Monday through Thursday, so we do have pretty much all business hours covered. We have a full R&D facility for our engineers to be able to test. This includes NPSH testing, which can be quite difficult with most companies. We actually have 2 30-foot tall columns that we can boil water in to be able to do that NPSH testing. And like I had mentioned, we have a lot of machines. We're almost out of space, to the point that a couple years ago, the president of our company did purchase a 168-acre plot of land just south of town here to build ourselves a brand new facility coming up in the next couple of years. One of the things I want to point out here is that our warehouse has millions of dollars in inventory that we keep on the shelves at all time. So we do have an expedite program. As long as the parts are in stock, we can build a pump with an expedite fee and get it out the door within about 24 hours, as long as we have all the parts. And at the same time, because of our knowledgeable staff, if you have a pump that you need because you have a customer down and we don't have the parts in stock, a lot of times we can go up a size or down a size depending on your condition points to still be able to get you something in that 24-hour window. All of our pumps are made to order, and every single one of them gets tested for pressure and performance, and leak tested to make sure everything is in working as it should before it gets shipped. Some of the associations and trade shows that we're involved with, the um, the IMEC is the Illinois Mechanical Engineering community, and we're involved. We're members of RETA, Refrigeration Education Technology Association, and a few others here. Like I had mentioned before, we are an ISO 9001 and ISO 14001, which we just got last year. Some of our in-house capabilities, this speaks to being able to make custom products for customers. We do have a full engineering staff. I think there's about 10 of them over there. They're in their own building across the street from us. We do have all the solid modeling design capabilities, along with rapid prototyping tools. We do have our own pattern and mold making shop, and we do own our foundry next door to us. The foundry next door to us, we outfitted a couple years ago with a small run investment cast stainless steel portion, where we can make 1 or 2 investment cast parts at a time. I don't know if you know anything about the foundry industry, but when you need investment cast, the typical foundry won't do any parts at small runs. They only do large runs of hundreds of pieces. And so with having that capability, if we're out of a part, we can get our foundry to pour that part pretty quick. And we do have our own returns and warranty area of our shop here, that we have 2 full-time employees that do nothing but break down and diagnose pumps to see what went wrong, if there was an issue with them, and to repair them. And another thing about our warranty, when you do send a pump in for warranty, as soon as we rebuild it, it gets put through the shop and retested and is in brand new condition when it leaves our facility, with a new serial number and a new warranty. So if you have a pump that fails within the 1-year period, and you need and you send it in here, when you get it back, it has another year that you're able to have warranty for. We'll look at some of these applications here. One of the biggest features of the regenerative turbine pump is that they're known for their high pressure with moderate to low flows. So what this means is we can hit up to 1,000 psi with some of our flex coupled regenerative turbines, and we can go out to almost 150 gallons a minute with some of our flex coupled pumps. And we can hit everything in between, including pumps that go to less than half a gallon a minute. It's still maintaining 100 psi or more. And so we have a very wide range for the regenerative turbine range, but very small in the world of pumps. To show you an example of one of our curves, this is a multi-stage regenerative turbine pump. And one of the main things to notice about a multi-stage regenerative turbine pump is that it is exactly backwards in the way the horsepower works from a centrifugal pump. So when you have a centrifugal pump, as you increase the flow, the horsepower increases. So if this were a centrifugal pump, the horsepower would go like this. But because it's a regenerative turbine, we have this sloping down. So the higher the pressure, the the higher the horsepower. And as you decrease pressure to increase flow, you end up decreasing the horsepower that you need. So it's kind of a unique feature. Here's an example of a centrifugal pump where you can see that as you increase the flow, you also increase the horsepower needed. So that horsepower is the opposite of a regenerative turbine. Some of the other characteristics found in a regenerative turbine pump, because they have such high pressure with just a single impeller, oftentimes they have a very compact design. If you compare that to a multi-stack centrifugal pump, a lot of times there's 15, 20 stages, and we're able to do the same performance that they are with just a single stage. So it's got a simple construction, low on maintenance, and the other quality is that when you're getting that high pressure, you're getting it pulsation free. When you have a piston pump or a gear pump or any kind of sliding vane pump, you have pulsation in the water or in the fluid being pumped. And with a regenerative turbine, it's a smooth flow, similar to a centrifugal, uh, but but with a much higher pressure. One of the other major qualities to a regenerative turbine pump is they have very good NPSH characteristics. When you have a centrifugal pump and you start pumping fluid that is, especially water that is close to a boiling point, the bubbles that would form in a pot when you boil water form inside the pump, and they collect in the eye of the impeller of a centrifugal pump. But in a regenerative turbine pump, all of the work being done on all of the fluid flow on the pump is on the outside of the uh, impeller. So any bubble action that does happen just leaves the pump immediately and doesn't have time to collect. Uh, so what happens is, instead of having a complete cavitation failure with a centrifugal pump, a regenerative turbine pump will just displace uh, the water with the bubbles, so it'll perform a little bit less, but it will maintain performance. So here's a little bit about the regenerative turbines. So using a centrifugal pump as a comparison, we have the water goes into the eye of the impeller and then is forced along the vane of the impeller to the outside of the impeller, where it goes across the volute and then exits right out of the pump. So when you have a centrifugal pump, the fluid being pumped only gets touched by the vanes one time. It only gets worked over one time. With a regenerative turbine pump, the fluid is introduced into the center of the pump, where it is worked on both sides simultaneously. And that makes the impeller balanced. And and when the when it's doing its work, when you need more pressure on a centrifugal pump, you would add stacks of impellers in front of each other to get that higher pressure. That flow being worked over and over again is done inside of a regenerative turbine pump, all with just one impeller, where it works the fluid over and over again as it's going across the water channel. So it enters in from one side and then it goes all the way around, and then it hits what's called a water stop, where it diverts the flow back to the discharge. So that's where it gets its pressure from, is all of these revolutions during its flow path. So when you have a multi-stage centrifugal pump, you have several stages. This goes up to 25 stages, but I've highlighted the 19 the 19-stage multi-stack pump here. And as you can see, there's a lot of highlighted, or I've highlighted this curve, and each model of just a single stage can cover any point inside of that curve. So it's a much steeper head capacity curve, but we can cover anything within this range. Another comparison is a rotary vane pump. This pump in particular is close to a Fluidotech or a Procon pump. It's a sliding vane pump, so it has moving this vane moves back and forth as it rotates, and as a result, you get pulsation and not as smooth of a flow, and you have parts that are rubbing. With the regenerative turbine pump, because the impeller is balanced, it doesn't touch any of the surfaces, and it also produces this pulsation-free flow. So we do have comparable replacements to Procon and Fluidotech if you're interested. When you get into a situation, especially with our flex coupled pumps, where you're getting close to boiling and your NPSH required is 16, 20 feet, sometimes 30 feet, and it's even higher in centrifugal pumps, and you need a little bit more performance out of the pump. We have an inducer that we can put in front of the impellers. It's similar to a centrifugal. It's called a Francis style centrifugal impeller, and it goes into a diffuser that ramps up the speed of the fluid before it hits the high pressure regenerative turbine impellers, and this can lower the NPSH sometimes as low as 1 foot, which is pretty good for any pump to be able to handle. Talk a little bit about air heating and refrigeration applications. So the first one here is booster service. Anytime you need to move any kind of fluid up multiple floors, regenerative turbine pumps are ideal for that. I know we do have several pumps in the Chicagoland area in some of the largest skyscrapers in the world, so we know they are used for that purpose. Another application here is in car and truck washes. Because of that smooth flow, it's very easy to work with, and we use them in several of our car washes across the United States. We have a water cutter and a water jet cutter, and what we use the regenerative turbine pump for is priming the main pump that is often a piston or diaphragm pump that is doing 20,000 psi or more to be able to do that cutting of the metal, and it needs to have a constant flow, so we use a regenerative turbine pump to give it several hundred psi before it gets to the main pump that does all the cutting. In this situation, I like to show this because we sold a couple of pumps to NASA that they used it to circulate cooling fluid up at the tip of the rocket here, and they stationed the pumps down below the rocket, so it had to boost that refrigerant up to the top here while it was on the launch pad. Once the rocket fired, it actually burned up the regenerative turbine pumps, and that was the end of them. They were a one-time use pump for that purpose. One of the first applications that boiler feed or that regenerative turbine pumps were used for was boiler feed. For those of you not familiar, when you have a boiler in a building or being used for any kind of cleaning or temperature type applications, that boiler is going to be under pressure. And you need, when the water that is going through that boiler is that hot, it turns to steam and goes through the system. Well, that steam will turn back into water and will empty the boiler. So the boiler needs to be refilled, and we use a regenerative turbine pump to pump water into the boiler because of the high pressure. Now, since this was one of the first applications for regenerative turbine pumps back in the early as the 40s and 50s, there have been several different boiler manufacturers, boiler feed manufacturers, and pump companies that have come and gone since then. And so every once in a while, you will come across a pump and or a boiler that you don't recognize. And so we've built this boiler feed selection chart so that if you can tell us the boiler horsepower and the pressure that you need in your system, we can tell you exactly which pump you would want to use to be able to keep that boiler in operating condition. So we have that for both our close coupled and flex coupled pumps, and this is available on our website under the boiler feed section of our website. To complement the boiler feed pumps, after that steam condenses back into water, it needs to go somewhere, and they use a condensate return tank. Well, the condensate return tanks traditionally have a flange mounted pump that's vertical to them, and so with the same as the boiler manufacturers, there are several companies that have come and gone. And when you need a pump replacement for a condensate return unit, we keep a flange mounted version of this pump of our T series available with these blanks. And we will actually, if you can tell us the manufacturer of the condensate return tank, we can cut the holes for you and trim it to whatever size it needs to be in order to be a direct fit right onto the tank. Now, if the tank is going to empty into a boiler feed, another boiler feed tank, you can use a centrifugal pump that's a lower pressure pump to refill it. But if you want to use that fluid that's in here that's already preheated from it previously being steam, you can use a regenerative turbine pump to pump it directly back into the boiler. So, and just like the boiler feed selection chart, we also have a jockey pump system pump. And for those of you unfamiliar, when you have a fire suppression system in a building, and the way it works is you have one very large pump that in the event of a fire will dump thousands of gallons a minute onto a fire through the sprinkler system. You have the sprinkler system that has the sprinklers that are held in place by pressure, and you have all the piping involved that needs to stay at a certain pressure in order for those sprinkler heads to not go off. So when there's a fire and one goes off, it relieves the pressure of the rest of them and they all go off. So to prevent that from happening accidentally, you use what's called a jockey pump or a fire maintenance pump, and you use it to uh, turn on every couple of minutes or couple of hours to make sure that that pressure is maintained inside the system. Because what will happen is you might have a drip somewhere on a floor that's not doing any damage, but just happens to be there lowering that pressure, or you have check valves that are going to go backwards to relieve the pressure in the system, and you need to maintain that. So you'd use a regenerative turbine pump as a jockey pump in order to do that, where it just turns on, repressurizes the system for a couple minutes, and then turns off. And here we have a selection chart that if you know the main fire pump rating, whether it be 25 gallons a minute or 4,000 gallons a minute, and you know what the system pressure is, you can select one of our pumps to be able to make sure that system stays charged at all times. When we talk about cooling systems, regenerative turbine pumps are often used for their high pressure for a couple different applications. In geothermal heating and cooling, water is circulated through thousands of feet of piping, and that piping has twists and turns and bends inside of it, or within its path, that cause friction losses. And when you have a number of friction losses because of this, fluid gets hard to move, and you need a higher pressure pump to be able to move it. And a regenerative turbine pump is very adaptable to that, so it can handle a variety of elbows and friction losses and still be able to maintain the same flow throughout the entire system. The other applications are any kind of cutting tool that uses a heating process for cutting, whether it be plasma or laser. They use a high pressure pump to put fluid through the tip of the cutting tool to make sure that every cut is maintained at the same temperature. When you're cutting with a laser, if you don't have a temperature control to it, that laser is going to heat up more and more. And so when it's making a cut, it's going to start out at a certain width, and the width is going to get larger and larger as it cuts, because that laser is going to be getting hotter and hotter. So they put the fluid directly through the head of the tool in order to maintain that temperature. One of the other applications here is regenerative turbine pumps oftentimes get used for a lot of different chillers, and a lot of chiller manufacturers like using a regenerative turbine pump because they have to fit the entire pump along with heat exchanger and other tools inside of one small unit that they often put in the same room as the item that is being cooled, whether it be a welding machine or an MRI. When you have a welding machine, they use the chiller to do similar to the same function as when you're doing laser cutting or plasma cutting. When they have it for medical use, sometimes it's being used for an MRI machine that they need to maintain the temperature so the lens is taking a consistent picture. Sometimes they'd use it for cancer treatment where you have a needle that is shooting radiation, and they want to make sure that that is staying in the same spot. And as that needle heats up, it would move, and they don't want that to happen. So they use a chiller in order to keep that temperature maintained. Some of the other applications here, we have high pressure, any kind of high pressure circulation needed, any kind of heat recovery, hydronic systems or boiler feed. You can use a regenerative turbine pump because it can maintain a steady flow with high pressures throughout an entire facility. Any kind of fluid transfer where you're going to need high pressure, you'd use a regenerative turbine. One of the things I wanted to point out here is this item right here is called a seal quench gland. And in the paper and pulp industry, there are chemicals that they pump throughout the paper making process that will crystallize if they are exposed to the outside atmosphere. And so when you have a mechanical seal, the mechanical seal works on two surfaces that have a very thin layer of fluid in between them. And when you have a fluid that will turn to crystal when it hits the air, as that fluid reaches the edge of the mechanical seal, you would end up with that crystallization slowly building away, eating away at the mechanical seal. So we came up with the seal quench gland that puts an oil barrier between the mechanical seal and the outside atmosphere, and it keeps oil inside of it. And the oil keeps the seal cool and keeps the outside atmosphere from touching any of the fluid that's in it. And it has a sight glass on it that we fill with oil that sits right in the middle of the sight glass. And what they do with it is they have a maintenance guy that will go through every once in a while and he'll look inside the sight glass. And if the oil on it seems to be higher or lower, or since they can see in it, if the oil looks like it's getting cloudy, then they know it's time to change the seal in this pump. And rather than have a catastrophic failure because of a sudden pump going down, they can schedule maintenance for it and be able to do that at their convenience. Another application is de-icing. When you have a fluid that you need to shoot onto an airplane on the tarmac, it's usually a very high pressure to go through the sprayer, and higher temperature. Regenerative turbine pump is ideal for that because of its ability to handle the MPSH and do the high pressure. One of the other applications, or a couple other applications here, are we have a whole line of stainless steel regenerative turbine pumps that work very well for deionized water and reverse osmosis. We have a canned motor pump, our X41 series, that is completely canned, so there is no mechanical seal. And when you have an area that it's critical to have clean fluids going throughout that area, or if you have a fluid that is absolutely necessary to not be able to leak, whether it's because it emits toxic vapors or whatever the reason would be, you can use a canned motor pump for that. Where they use them in infrastructure is there are hospitals and other critical buildings that will have fuel cells outside of their buildings that in case of a power outage, they can use a fuel cell to maintain the electricity, and they use the sealless can pumps throughout those for temperature control and for moving all the fluids involved with that process. One of our newer products here is our HP series hermetically sealed refrigeration pump. It's actually a regenerative turbine pump that has all of the motor and the pump itself contained inside of one can that is welded shut. So there's absolutely no way there can be any leak. And because the motor and impeller are working together in the same unit, it's actually a wet wired motor. So only non-conductive fluids should be used through this. Non-conductive fluids include freons and CO2. And where they use these is they use these in what's called an economizer package. And the economizer package, what it does is when you're in a building that has refrigeration, whether it be a data center or a grocery store, that refrigeration is most often being cycled through a system that is using a compressor. When you have a compressor that is 20 or 30 horsepower, it's using quite a bit of electricity and it has to run full time in order to maintain that temperature. What we've what we've developed is our pump works along with this economizer package where they can run a heat exchanger outside of the building. And when the climate is lower than the temperature of what you're trying to cool, especially in the northern states and other parts of the world where there's where there's lower temperatures throughout different parts of the year, they can actually turn this compressor off and use that's 20 or 30 horsepower and use our little 1 or 2 or 3 horsepower motor that's inside of our sealess pump here to do the job of that 20 or 30. When you have a building that has repetition where it's using 20 or 30 compressors at one time, and you can shut all of those off to be able to use a 1 horse motor instead, the savings in electricity uh, and the costs involved with it are pretty extensive. Um, so now we'll talk shift gears a little bit and talk a little bit about water and wastewater applications. Um, our first wastewater application here is DAF, and this kind of goes against the grain of what you would normally use a regenerative turbine pump for, that we don't use this pump for the pressure for this application. We use it for the ability to shear oxygen or any other gas along with the fluid being pumped to make what's called a microbubble. This video here is showing how it kind of makes smoke inside of the water, and what that is that's tiny air bubbles that when you have contaminated water that's dirty, it will grab onto those little bubbles, will grab onto the objects that are the debris that's in that water, pull it up to the top where it can be skimmed off, and then they can either clean the water off enough to be put down a normal system instead of stored or rendered later, or they can reuse the materials collected and reuse the water for other services. The biggest places that we see those are in the food processing industries. A lot of times when they finish their all their processes to make any type of food, they're left with a dirty water that is too dirty to be able to put into a normal wastewater treatment facility. Uh, in some cases, they have to store that in large storage tanks and then have it hauled out to a rendering plant or to a place to have it reconditioned. But with a DAF system, you can clean that water oftentimes enough to be able to put down uh, the normal wastewater system and not have any effects on that system. One of the other applications that we found this get used for is in the oil and the oil fracking and shale industry. When they use a super high pressure pump to pump all that water in, they end up to get the oil out of the ground, they have to pull the water back out. And previously to using a DAF system, they were just storing it as toxic waste. When they started using a DAF system, they realized that they cannot clean the water enough to be able to put down a normal wastewater system, but they can clean the water enough to take it to a different site. So they can save millions of gallons of water in this process by reusing it over and over again. And with our pump, the way it works is it can pull air into the inlet side of the pump and do all the mixing, and then have the discharge side of the pump already mixed with the micro bubbles. And what that does is that allows a system to save the need for compressed air or any static mixers or large centrifugal pump needed to move that much fluid, along with any of the pressure vessels and a number of other parts. So there's a lot of maintenance that is saved and a lot of startup costs that are saved when you use a regenerative turbine pump. Some of the other applications here, any kind of system where you have moving fluid and you need to use a higher pressure uh, pump to backflush that fluid in order to clean or change anything, you would want to use a regenerative turbine pump. So some of the samples here are seal flushing. When you have a very large pump and it has a mechanical seal that is very labor intensive to change, and it's a very expensive seal, and you want to keep it protected, you would use a small regenerative turbine pump to run a direct line of clean water into that pump. And by having that clean water go across the seal chamber, it keeps it clean and cool and extends the life of that seal. With the filter back flushing, any kind of filtration system that you have, as the filter is in operation, it has a buildup of debris, and you can use a regenerative turbine pump to backwash it to blow all that debris that's built up out of the filter, churn it up, and extend the life of the filter so you can use the filter longer. With extractors, they use those more for large engine type applications, trains, locomotive, and marine applications where they have a very large engine that is very difficult to stop and restart. They can do fluid changes in that engine without needing to turn off the engine, because the high pressure can overcome what the engine is producing as it's operating. And the groundwater remediation is very similar to the filter backflush. You have a number of grates that have holes in them that catch debris as it's flowing through any water source, and you can use a regenerative turbine pump to backflush that. One of the other products that we have here is we have a 12-volt DC motor. We have, in this instance, it's connected to a centrifugal pump that is a DC-10 pump is what this is called, and there's a few other companies that have a very similar product. The difference being that ours is all stainless cast materials and very heavy duty. But the advantage of having this 12-volt motor is that the same motor that you use for our centrifugal pumps is also used for our T31 and E41 and E51 series. So any one of our close coupled pumps that require less than 1 horsepower, we can connect to this 12-volt motor, and you can have a portable pump that way. One of the other applications here, and I wanted to point this out, is we do have bearing frames for all of our close coupled pumps. We had a particular customer that wanted to use the pump on a bearing frame so that they could have it PTO driven using a hydraulic drive. So they could have it in line with other equipment that they were running, and this particular customer was using it to put DEF fluid, the urethra, the diesel exhaust fluid, into agricultural equipment while they were refueling it as well, so they could do both at the same time. One of the other applications here is high pressure coolant. We have a couple of companies we work with that have found that by using a high pressure regenerative turbine pump in their coolant system for their CNC machining, they can use it to put a precise nozzle onto a cutting tool. And what that does is it makes the cutting tool make a cut consistently throughout the entire process of the part, without with extending the life of that cutting tool, and making more accurate parts so they can run parts faster and have the tools run longer by using the high pressure coolant. Any kind of manufacturing facility that makes any kind of tank, valve, other pumps, and piping need to have a method of making sure that the item that they've made can maintain pressure. And so what you can do is use a regenerative turbine pump to pump fluid up to whatever pressure you need to with using a pressure gauge, and then you can shut it off and be able to test the pipe or tank or pump for any kind of leaks that may be happening after pressure is applied. Along those lines, we have pressure injection. We can use a regenerative turbine to pump creosote into wood inside of a pressure vessel to be able to make that creosote go into the wood to make pressure treated lumber. They also use a similar method for putting curing agents into concrete so they can control how the curing time works based on the weather conditions for the day or where they're at geographically. Another application here is spraying, just like the car washes, any kind of spraying that may need to be done for anything from street cleaners to food processing. Regenerative turbine pumps work very well with different kinds of sprayers. One of the other applications here is in misting. They use this for dust control in construction and demolition sites, where they use a regenerative turbine pump to put water through a nozzle at the front side of a fan, and that fan blows a mist into the area to water down all of the dirt and dust that's in that area for dust control. Some of the other applications here are laboratory equipment. Because we have very precise models to our pumps, we can oftentimes select a pump within a half a gallon a minute of what would be needed for any kind of precise technical pumping needs. And so we have a number of pumps that get used for laboratory equipment. We also have sampling pumps that they can take fluid from any point inside of a large facility and move it through a number of twists and turns and bends and piping to be able to get it to a centralized location for sampling. Some of the optional materials that we have are standard material for most of our products is bronze fitted. That is a bronze impeller with iron casing and motor bracket. We also have all iron available as well as all bronze and 316 stainless steel. We have a number of O-ring materials available as well as seals, and some of our options include vertical flanges, seal flushes that seal quench gland that I showed earlier, injection ports, relief valves, strainers, and we can passivate all of our stainless steel products as well. We do have a full sales staff and at all times. So if you ever need anything, please call us and we'll help you in any way we can. Some of our upcoming projects that we have going on. One of the things we started earlier this year is the MTH School of Pumps. And what that is we extend an invitation to any of our distributors to come to our factory for an intensive 2-day training course where we go through all the ins and outs of our pumps, and we are able to show you our facility, and we spend some time um, working on pumps out in the shop and building them. And we've already done 3 of them now. The next school of pumps that we have scheduled is actually in February, and that is going to be our first all Spanish speaking school of pumps. We actually have a number of our distributors from Mexico coming up to partake in this event. Some of our products that we're working on, we have our engineers working on a mag drive adapter that's going to be able to turn any one of our T series pumps, our close couple pumps, into a mag drive configuration. We're also in development of an ammonia transfer pump for the large refrigerated warehouses to be able to um, move ammonia from one location to another at a much cheaper process with one pump versus a typical ammonia transfer setup where you have a series of tanks and a series of stages that multiple pumps have to move from one tank to another to build up the pressure. We're looking to use a regenerative turbine pump to do all of that with just one pump. And one of the things we're kind of excited about is we just had this summer, we just had solar panels installed. There's over 600 of them on our roof right now in operation. So that is doing quite a bit for taking care of a lot of our electrical needs. Um, and that is pretty much all I had for today. If anybody had any questions and you want to ask anything, please use the chat or the Q&A on the webinar form here. So it looks like we're pretty much set for the day. If you do have any questions, you'd like to talk to me later, I will be available. Or you can drop me an email at publishing@mthpumps.com. And really appreciate you guys taking the time out of your morning here to do this. And we are having another one of these webinars this afternoon at 2 o'clock Central Time that we're going to talk a little bit about pump selection, particularly with the pump selection of regenerative turbine pumps. So thank you very much for being here, and enjoy the rest of your day.